This video will cover Chapter 24, Comparing Two Means, Confidence Intervals. We're going to be following up on the same problem that we looked at when we were comparing, or when we were creating a hypothesis test for two means. And so again, let's review our question. We are looking at how smoking affects heart rate. And we have a random sample of 26 smokers, 32 non-smokers. The average heart rate for the smokers was 80 beats per minute with a standard deviation of 5. And the average heart rate for the non-smokers was 74 beats per minute with a standard deviation of 6. The distributions of both samples were unimodal and roughly symmetric with no outliers. All right, so again, we're looking at the difference in the average heart rate between the smokers and non-smokers. But instead of doing a hypothesis, we're going to create an interval for the difference between the two means. All right, so looking at our problem, we need to make sure that we've established our conditions to be true. And since we did that in the last video, I'm going to just go with those. Nothing about these change. So we've already proven them to be true. So we are ready to move on to our confidence interval. So the mechanics of a confidence interval are the same. We take a statistic and we add or subtract a margin of error. And our margin of error is made up of two things. It's made up of a critical value and a standard error. All right, so all that changes is how we get our critical value and what our standard error is. So in this case, our statistic is the difference between our two sample means. So the mean of the smokers and the mean heart rate of the non-smokers. That's our statistic. And, I guess we should establish what level of confidence we want. Let's say we want to make a 90% confidence interval. All right, so then we need to establish our critical value. So our critical value for right now, we're going to list as T star, certain number of degrees of freedom. And our standard error is going to be calculated just like our standard error was calculated in the last video when we were doing our hypothesis test. We take our standard deviation for our sample for smokers, divided by the square root of n, but because we're putting two distributions together, we're converting that to variance. Now, of course, another way we can write this, because when you square a square root, the square root goes away, so I'll show you the other way to write this. We could just simplify this to be s squared over n. So we'll do that for this one as well. So we're going to take the standard deviation for our non-smokers and square it and divide it by the number of non-smokers that we have. All of that will then be square rooted. All right, so before we use our calculator to create our confidence interval, we're going to call out our various variables, or our various inputs that we're going to put in here. So y bar smokers is 80, and we had the number of smokers was 26, and the standard deviation for our smokers was 5. The mean for our non-smokers was 74. The number of those non-smokers was 32, and the standard deviation for our non-smokers is 6. All right, so the only thing that we haven't yet figured out is what our critical value is. And remember from the last time, our degrees of freedom are n minus 2 in this case, or what we get from our calculator. It's a reasonable rule of thumb to use n minus 2, but our calculator will definitely give us a better value, but we came up with 56 for the last problem. Okay? So in order to figure out what our critical value is, we're going to go back to our table. And again, told you that we would, in the last video, that I would show you, or I would load onto your calculator the correct function for this. So since we don't have that all in our calculators yet, we can learn how to use these tables. So going to the formulas and tables that I give you for every test, and the AP also gives you, if we scroll down, you guys would flip pages, I suppose, we look at our T distribution for critical values. And we're going to go to, so the columns are, the left column is the degrees of freedom, and the top row is the tail probability. All right, so remember, we're doing a 90% confidence interval, which means that each tail contains 5%. So we're looking at this column right here, where we're looking at 5%, 0.05. And our row should be our degrees of freedom, which is 56. So we're going to go read over to approximately 56. So we want somewhere between 50 and 60. Okay, over to 0.05. So we're looking at 1.676, 1.671. So why don't we call that 1.673 or something like that, okay? So, or 1.674. Either one would be fine. All right, so 1.674. All right, so now we can just go to our calculator and have it do the confidence interval for us. Stat tests. And we want to scroll down until we get a 2-sample t interval. We have statistics, and luckily I have what we had in there the last time, so I've already got everything entered in. And we want a confidence level of 0.9, or 90%. And again, we're not pooling. We're never pooling for comparing two means, only when we compare two proportions. I'm going to say calculate. Just got to think really hard, and we end up with a difference of 3.584 to 8.416. Okay, so our last step is simply to put it into context and say what our confidence interval means. Okay, so we can be 90% confident that the average heart rate for smokers is between 3.6 and 8.4 beats per minute, higher than the average heart rate for non-smokers. Okay, so notice I didn't just talk about the difference, because you specifically subtracted non-smokers from smokers. So what you're saying when you have two positive values here is that the smokers' heart rates are consistently higher than the non-smokers' heart rate. So that's really important to include in your interval, in your description of your interval. All right, and the last thing about this, if we were to have used this for our hypothesis test, remember where our null hypothesis was that mu sub s minus mu sub n, the difference between smokers and non-smokers, is 0, versus the alternative that the difference is not 0, is something but 0. This actually, our interval supports our conclusion in the last video to have rejected the null hypothesis and say that we have enough evidence for the alternative to be true. Because what we did find, all of the values in our interval are positive. Okay, none of the values are 0 is essentially what we're saying. All right, so because 0 is not in our interval, because our null hypothesis value is not in our interval, we would have rejected the null to claim the alternative to be true. So anytime you're using a confidence interval for a hypothesis test, in lieu of a hypothesis test, what you care about is whether your null hypothesized value is in your interval. If it's in there, we cannot reject the null. If it's not in there, we do reject the null. All right, so that concludes our work with the comparing two means.